Okay, so today we're just going to review some of the things that we went over um what was it? Wednesday or Monday? Monday, yes, Monday. And then we're going to talk about the calorimetry stuff. And then we're going to also talk about enthalpy and energy and how you can solve um, for whether something is endothermic or exothermic and things like that. And then we'll review the rest. And then you said that you spoke to her about the, solving specific heat and things like that.
Yeah.
And you're more comfortable with that based on our discussion, but not based on what your teacher said.
Yeah.
Okay. Did you do any questions with her?
I did do some.
And were you able to answer?
Yeah, I was able to answer them, but that was kind of because like we had went over everything beforehand, so that I understand what we're doing.
Okay, cool. Makes sense. Just get my life together over here. I don't know why this is happening. 1 second. Interesting. You can see my slides, right?
Yeah, I can see it.
All right, awesome. So like I was saying earlier, we talked about pretty much everything that I have on this check mark, right? We talked about how to calculate heat gain, right? By using the formula, which was either CQ divided by mass times temperature, right? And like I said, in order to do that, you have to either rearrange your equation, and then when you rearrange your equation, you have to make sure that you're writing down your knowns and unknowns on the side of your paper so that you can make sure that you're keeping track of your numbers, right?
Yeah.
Is that strategy working for you?
Yeah, it is.
Okay, so and then we talked about the numbers in scientific notation, vice versa, and then we compared numbers written in scientific notation. So I think you're pretty much good with that. I think the only thing that we haven't talked about in column C is identifying reactions, endothermic or exothermic. We'll talk about the definition of that, and then I think I briefly talked about how to indicate arrows of heat flow between two substances of different temperatures. Briefly, do you remember that?
Yeah, I do.
We'll talk about that a little bit as well. And then we use the law of conservation of energy to solve for mass, right? We did that. We did the, what is that? Calculations or numbers, some specific number and significant figures, round calculations. We did that. We did, and then I'll just do the definition of conduction, convection, and radiation so you know that clearly. Then we did in column A, we've done the proper number, significant in all calculations, and then column A, use of law of conversion of energy to solve a final temperature, right? And like I said, remember, you really have just one, you really have just one equation, right? And you just rearrange that. Do you see that?
Yeah.
Right? Okay. And that makes it easy for you, right? So we'll just be talking about like 5 things today, and I'm going to try to do all of them in an hour so that you can be prepared for your class, but it's very for your test, but it's very possible, and you probably that will go over an hour. You should probably, I don't know, I should have told your mom when I texted her today. But when I was going over everything and I saw that your calorimetry homework was 7 pages.
Yeah.
I was like, oh my God, like that was a lot. Anyway, but we'll go over those today too, just so we can make sure that you're able to kind of decipher through those practice questions. So the first thing we're going to go over is conduction, convection, and radiation, right? Do you have any thoughts about what this means?
I know that think I know what it means. Like it's like the way the heat is like getting around, right?
Right. But there's a very subtle way of differentiating everything. Right. So we'll talk about that so that you know, because you're getting tested on this tomorrow. So there's different type of ways that you can transfer heat, right? Usually
Yeah.
when you're talking about heat, you're talking about a system, right? And those three types of heat transfer is conduction, convection, and radiation, right? And the picture that I have on here pretty much just tells you the differences between these three types of heat transfers, right? One is direct, meaning you're actually holding something. You know, it could be a spoon. You're holding something and you're putting it on, you're holding something and you're putting it on like a burner or something like that, right? And you're transferring the heat to the metal. That's conduction, right? It involves a direct transfer of heat through a substance without much of the substance, right?
Yeah.
I said, it's this picture here, right? And this picture here is showing you that I'm holding something and I'm, you know, it could be a spoon, and that spoon I am putting into heat, meaning that that heat is transferring directly, right? Convection is different, right? Convection is a little bit different because we're talking about the movement of what actually happens when, for example, a metal will absorb heat, right? But if you were taking solid and you are melting it, just like if you were using candles, right? You see that transfer of elements, right? You're seeing the transfer of element from solid to liquid to gas, right? That is convection, right? It involves the transfer of heat through flowing current, right? An example of that is water, right? When you boil water, you see that transformation from liquid to gas, right? Through the open flame, right? Does that make sense? So it's like the movement through different types of elements. Does that
Yeah.
make sense? So now you can see the difference between one, just conduction versus convection, right? Because conduction is direct, then convection is indirect.
Yeah.
Right? Now radiation, now we're talking about like protons and electromagnetic things, right? Because now we're talking about transfer of heat involving like molecules, particles, right? Like proton, kind of like using, you know, using your microwave to reheat your food, meaning you're using those different molecules inside the microwave to try to heat the food. Right? It's like it's the radiation is just like the beam of heat, right? The protons, the molecules that are colliding with each other, creating something that is essentially transferring heat.
Yeah.
Right? So now when you get an exam on this, you can essentially just differentiate between like, okay, we're talking about conduction here because I'm holding a metal through a fire, you know, or I'm using a candle, or is a pot on the water, which is convection, or are we essentially specifically talking about radiation, or you were now talking about electrons and protons and how they can be, how they behave or interact with each other. Does that make sense to you?
Yeah, that makes sense.
Okay, so in your words, how would you explain that? Just so you know how to identify these when you get a test, when during your exam.
So conduction is heat traveling through an object, and then convection is heat flowing a certain way, like off, I guess whatever's creating the heat. And then radiation is like the little, what do you call that? The little, I guess, radiation particles, or some, not radiation particles, but like, it's like radiating heat off of it, like making it just kind of go like from here all the way to here.
Exactly. So I think the important thing to recognize with that is with the first two, you require something that you can either see or touch, right?
Yeah.
But with radiation, it doesn't require matter. Like it's literally things you are, like magnetic, electromagnetic radiation, which means you're not able to see it, but you know that molecules are working together to create that heat transfer.
Yeah.
Does that make sense?
Yes.
All right, so that was the first point, and I hope that you're able to get that when you do your exam tomorrow. And then now I wanted to kind of briefly go ahead and talk about two endothermic, exothermic reactions, right? Endothermic and exothermic reaction is just the study of thermochemical processes, right? Right?
Yeah.
And then usually when you're thinking about these two different types of system, you're thinking about it from a point of view of a system, right? Either one system, either it's absorbing heat or losing heat, right? Right? When we're
Yeah.
talking about endothermic reaction, we're talking about something that is absorbing heat, right?
Okay.
And it's absorbing the heat from the surrounding, right?
Yeah.
Now, exothermic reaction is heat release, right? Meaning
Yeah.
you're releasing the heat, right, from the system into the surrounding, right? From the
Yeah.
system into the surrounding, meaning candle, right? Heat, combustion reaction, exothermic reaction, right? We're releasing the heat into the surrounding versus,
Yeah.
heat absorbed from the surrounding.
Yeah.
So you're decreasing temperature in endothermic, you're increasing temperature in exothermic. You're decreasing temperature in endothermic because you're absorbing the heat into the system. You're increasing the temperature in exothermic because you're releasing the heat to the system.
Yeah.
Make sense?
Yeah, that makes sense.
Okay, and usually in endothermic and exothermic reaction, especially in endothermic, you get a positive. You use that as a positive after. Do your other homework first. Sorry. Endothermic is positive and then exothermic is negative. Okay, just remember that because that's going to be important for when we do a practice question on this. So can you hear me?
Yeah, I can hear you.
Okay, sorry, my neighbor is loud. Excuse me. So endothermic and exothermic reactions, right? We said one absorb and the other release, right? And usually you quantify endothermic and exothermic reactions by using something that is called enthalpy. And enthalpy is delta H. Enthalpy just tells you that there is a change in the heat within a system, right?
Yeah.
It measures the heat content of a system, right? So a positive delta H means that you have gained heat into a system. And a negative delta H tells you that you have lost heat in a system. enthalpy can be represented in joules over moles. It's everything that we've been doing. When we talked about energy conversion and heat transfers, that is kilojoules, right? We've been talking about this. This is just kind of like the missing piece of everything that we've been talking about, right?
Yeah.
We were talking about the heat flow, right? Now we're talking about what does it mean when we release heat? What does it mean when we absorb heat? Right? This is the next phase of heat flow. Right? Does that make sense?
Yeah.
And this, I'm not sure if your teacher talked about this a little bit, but if you were given a graph of what exo and endothermics looks like in a graph, you will see that when an exothermic reactions happen, your graph is gonna look like it's releasing heat. And usually when it comes down like this, it's losing heat, right?
Yeah.
Exactly. And then
Yeah.
they usually have this activation energy, and the activation energy is the energy that it needs in order to get over the hump.
Yeah.
Right? And once it gets over the hump, we go into this transition state. And the transition state just means that the chemical reaction, the chemical bonds are starting to break apart. It's transitioning, it's becoming something else. It's like your combustion reaction turning into water and CO2, right?
Yeah.
In this case, you will see those bonds starting to break and becoming something else. And then once the heat is released, you get this exothermic reaction. Does that make sense? I don't know if you're following, but for example, you know, what we did earlier with the candle, right? This is just your hydrocarbons. Once it hits an activation energy, just enough energy to begin to break bonds, that hump is going to then begin to transition to a whole new molecule, CO2 and water.
Yeah.
Plus heat releasing, breaking bonds is at some point, breaking bonds create energy. I mean, breaking bonds takes energy, forming them releases them.
Yeah.
Right? I hope that makes sense.
And my mom, I think, emailed you like I think it was a practice. Yeah, it was a practice test, and she wanted to know if you got it.
Let's see. When did she send it?
I think she had just sent it right now.
Okay, give me a second.
Yeah, it's almost completely done. There's just a few questions I was like having trouble on. It's like the equations and stuff like that.
I haven't gotten it. Which email did she send it to?
Let me ask her.
When did you get this practice test?
I just sent her saying it. I had to text her and see if she got it. She sent it. No problem.
Okay, I got it. Oh my God, everything we've been talking about. I'm looking at it. She sent it to my other email. Let me forward it to my business email because that's where I have all of your stuff.
Okay.
Well, this is basically everything we've been talking about. So this is perfect, right?
Yeah. Yeah, I had forgot to send it to you. I was like, oh, I remember I had that in my backpack. I was looking through it and I saw it and I was like, okay. And then I just walked out of the house and my brother's walking downstairs. Like, can you hand this to him or my mom real quick?
Okay, so we're talking about the right things. So this practice is going to be your test on Friday.
Yeah, it's gonna be very similar to that. Some of the questions on there may be the same, just like two different things on it might be different.
1 second. For some reason that just didn't send right. Forward with the documents. Include. Yes, in this case. Okay, 1 second. So this graph that we're talking about is on your test, which is like,
Yeah, I had recognized it.
which is awesome. Let me just make sure. Okay, so this question is saying the capacity of doing work or supplying heat. Okay. Energy that is transferred from one object or substance to another because of a difference in temperature between them. Also like energy transfer. A process by which heat energy is released by the system, yes, into the surrounding, yes, that is exothermic. We just talked about it. A process by which heat energy is absorbed by the system. Yeah, endothermic, we just talked about it. Does that all make sense since we talked about that?
Yeah, it makes sense.
Okay. One second.
Yeah.
Okay, so, and then he said, draw arrows in the picture below to indicate direction of heat of energy flow from the pack of hand, what? From the pack to the hand, okay. From the pack to the hand, or from the hand to the pack. What kind of pack is that? I can't even see that. What is that?
So the first one I believe is a cold pack, and the second one's a hot pack.
Oh, okay.
It's like hand warm, like hand cool or something like that.
Oh, I see. So a cold pack was the first one.
Yeah.
Okay. The heat flow. Wait. Draw, indicate the direction of energy flow. And you said that your hand is warmer, right?
Yeah.
So the heat is going to go towards the pack.
Yeah.
And then the other one is a hot pack. So
Yeah.
that
The other
heat
one.
is going to transfer to your finger.
Yeah.
Right. Okay. What did your teacher say about the one when you did that?
She said it looks good and that I was doing it all correctly. Some of it's crossed out because I had written in pen, and I was like, okay, that doesn't sound right, so I went over it. I
Which
gotta
one
get a
is crossed
pencil.
out?
I'm not sure which one. I don't have a test in front of me because my mom took it and then I walked out of the house.
Oh, okay, no worries, don't worry. I didn't see anything crossed out on here. All I saw was the you were marked wrong for what the definition of endo and exothermic reactions, which I'm glad we're going over today.
Yeah.
And then write the answer here. And you said endothermic. Oh, yes, yes. Please remember, if you don't remember anything else, because I saw that you got this graph wrong, this is endothermic reaction,
Yeah.
right? And you know why?
That's endothermic because you have two, what do you call those? The two starters, I guess you can call them. And then it goes all the way up and it kind of goes down and it just kind of like goes flat, like a flat line almost. And then that's how you can tell it's endothermic. If it was exothermic, it would go right back down. It wouldn't have that line.
Right. And that and the way to explain that is the way the other one doesn't, the reason why the other one doesn't flatline is because heat is not being released, it's being absorbed. Okay.
Yeah.
And in exothermics, it comes back down because it is kind of like blowing air. It's like I inhaled and then I released all of the air, you know?
Yeah.
Okay. But endothermic is still it's like you know, if you were cold and then you go in front of a heater. You're absorbing that heat.
Yeah.
That makes sense.
Yeah.
And then the delta H value for reaction is negative 178. In this reaction is endo or exo. This is exothermic. We're going to talk about this as well. Okay, we're going to talk about that as well. Okay, so I'm going to move on from this. Do you have any question on this? Hello?
Oh, my bad. I couldn't. I was like trying to fix my computer. It like went quiet. Okay. Could you repeat that?
Do you have any question on these graphs?
I have no question.
Okay, this makes sense.
Yeah, it makes sense.
Okay, so here it is. Okay. Oh, there's something right here. I don't know what that is. But like I just wanted to read this to you. So in enthalpy, there is an equation that you have to use to find out whether something is endo or exothermic. I don't know if that's something that you guys have to do to calculate what the delta H is, to calculate what the change in energy is, right? Right.
Yeah.
And the to calculate enthalpy, right? That's just the sum of standard of enthalpies, right? For whatever reaction you have, and we'll do a practice question on this, right? So, and I'm
Yeah.
thinking that like if you were getting tested on this, your teacher is going to give you the amount of heat if she was talking about a specific reaction, right?
Yeah.
Right. I'm thinking that that's how she do, because it'd be impossible for you to like generate it yourself. Okay, so negative enthalpy change for reaction indicate exothermic reaction, right? We said that already. And a positive is your endothermic reaction. So positive is endo, negative is exo, right? Yeah. You know, if you wanted to like remember this, know that your X creates a negative impact in your life. Right. Okay. And when you work on yourself, within yourself, your endo, you create a positive impact in your life. All right. And then so when I said earlier that like you have to calculate standard enthalpies within like different reactions, when I'm saying your teacher should give you the amount of kilojoules of heat for different like bond formations, right? Like CH4 is negative kilojoules per mole. You know, oxygen usually by itself is 0 kilojoules. CO2, this is just what we've been talking about. This is combustion reaction, right? CO2 is negative 304 kilojoules per mole. And then water is negative 284 kilojoules. But all these different energy values are going to be given to you by a teacher. And then you will then be required to calculate what the delta H is, what the change in enthalpy is, and then figure out whether it's positive or negative to figure out whether it's the heat is being absorbed or released. Make sense?
Yeah.
And this is just like an overview of what, because we're going to do one together. Right? Okay, so this is the example that I was talking about earlier. So now I'm talking, this is like, you know, calculating enthalpy, right? So let's say you were given this problem right here, where you given H2 plus F2 equals to HF, right? We know that bond energy is in kilojoules, right? KJ for hydrogen bonds, fluorine and HF, right? And we know that the different energy values for these are 436, 158, and 568 respectively. These different energy moles, you should you should get from your teacher, right? Right. So now when we figure out what's actually happening with the reaction, right, we're saying that when we're looking at it, it's clear that 1 mole of H bond, H and H bond, and 1 mole of F and F bond will make 2 moles of hydrogen fluoride, right? We see that right here, 2 moles. 1 mole of hydrogen bonds, 1 mole of fluorine bonds will make 2 moles of HF, right? And we said earlier, breaking bonds require absorption of energy. And then when we form them, we release. When we break, we absorb. When we form, we release.
Yeah.
So here we said to break 1 bond of hydrogen bonds, it's 436 kilojoules. To break 1 mole of F2, you absorb 159 kilojoules. And then to form 2 moles of hydrogen fluoride, 2 times 568 kilojoules is going to be released. So when you're applying this equation and you're trying to find delta H, the equation is going to be, right, delta H equals the change in the bonds broken, which are your reactants. These are your reactants. This is your product. Change in your reactants, which is going to be your H2, right, plus F2, right? And we said that the energy absorbed is going to be 436, right, plus 158, right?
Yeah.
Minus, because we're subtracting, minus the change in enthalpy for whatever 2 times 568 is, right? Right? And then when we add the reactants minus whatever we have in our products, that is the total. Is going to total to negative 542. Right? Which means, what does that mean? What does our result mean?
That means that is our that is our 2HF, I think.
Yes, that is our 2HF. But when something is negative, what do we say what that was?
Oh, it's exothermic.
Right. This means that it's an exothermic reaction, which means what?
Which means that energy is released.
Right. We are releasing 542 kilojoules of energy. Right?
Yeah.
Okay. Does that make sense?
Yeah, it makes sense.
Okay, so I'm looking at the practice test some more. Okay, let's see. Also, you were given a practice test on whether something is a conduction, radiation, and a convection. So that's good because we talked about it, right?
Yeah.
The heat transfer of energy through movement of particles. What is that? That are in contact with each other. What is that?
That is radiation? No.
In contact, direct contact.
Conduction.
Exactly. The movement of energy through empty space in the form of electromagnetic waves.
That is radiation.
Exactly. The process by which heat is transferred by movement of heat fluid, such as air or water?
That is convection.
Okay. You're not looking at this, right?
No.
Okay. All right. And now it says ethanol has specific heat of 244. 244, I'm looking at your practice test, okay? Because I saw that you didn't solve this problem.
Yeah, I did.
Ethanol specific heat is 244 joules per grams Celsius. Ethanol's temperature is 15 Celsius when it is heated. In the process of ethanol, the ethanol absorb 569 joules of energy. What is the mass of ethanol? Show your work. Okay. What did you struggle here?
I kind of like how to set up the equation.
Mhm.
If I know how to set up the equation, I can do it. It's just I didn't know how to do it. I set it up.
Okay. Remember, I told you all you have to do is rearrange the equations, right?
Yeah.
Now, it's kind of like algebra. Like now your x is mass, right?
Yeah.
Okay. So how would you rearrange that equation? Just an idea. But tell me what you do if you had to rearrange that equation.
I'm not too sure.
A second, something is talking to me. My headphones. What is going on? Am I using Siri? Okay. Okay, so you know how when we were looking for heat, it was C equals Q, right? Over mass times change in temperature, right?
Yeah.
It's the same thing. Mass equals Q, right? Then specific heat times temperature.
So it would be. Oh, I thought I'm doing this wrong. I don't know. I feel like I'm doing it wrong.
So if you were writing down all your knowns, you would say that I know specific heat, right, which is 244 joules per gram Celsius. I know energy because it was absorbed. It was 5,696, right? That is your energy, right? I know temperature because it was given to me, right? Temperature is 15 Celsius, right? So now because I'm looking for mass, I'm just gonna plug and chug everything. I know that Q up above is going to be 5,696 joules divided by whatever 2.44 joules over grams Celsius, multiply that by 15 Celsius, right?
And could you also put that page up on the screen so I can kind of see what it's like?
Right. 1 second. One second, I'm trying to get out of the thing. Okay, 1 second. How do I put this in here? Okay. Here we go. Can you see?
Yeah, I can see that. So you write it down as.
So in this situation, remember, just write down all the knowns, because let me just take a picture of this actually. This is what I'm gonna do because I want this to make sense. Whoa. Oh, we haven't even done the calorimetry stuff. 1 second. Okay, this is what we did last time. I'm gonna just add this here, new slide. Okay, you looking at this? You see this?
Yeah.
Okay. All right, so like what we were saying earlier, right? From the last, remember this from last time?
Yeah,
This
I do.
E equals, right? Remember this from last
Yeah.
time? You're just literally switching things around. It's because now you're looking for mass, right? So instead of like doing, because last time you were looking for specific heat, right? Specific heat was CQ. And this is just your energy, right? The sign for your energy, which is mass times change in temperature, right?
Yeah.
Now you're doing the same thing. You're now looking for mass. Mass is your X, right? Right.
Yeah.
You have Q, you have C, and you have delta A, delta T. Delta T is 15 Celsius, right? Because, based on the question, this is 15 Celsius, you have specific heat, and then you have energy. Those are your equation, right? Specific heat is 2.44 joules per grams Celsius. And then Q, it says, was absorbed 5,696 joules, right? So now to solve for mass, that is the same thing. Q, right? C times change in temperature, right? So you just plug and check. 56, 9, 6 joules times 2 divided by 2.4. Make sure you're using your units, joules per gram Celsius, times 15 Celsius. Right? So joules, Celsius, Celsius. Whatever the answer is, will give you grams. Make sense?
Then
Does that make sense?
yeah. So then so I'm just gonna use it. 2 1 180. would the answer be 163?
Yeah, so the answer would be
163 grams.
grams, right?
Yeah, can't forget that.
Okay, does that make sense?
Yeah, that makes sense.
So just make sure you're following your equations, right?
Yeah.
Right, so you know your equation for everything else when you're looking for temperature and just heat,
Yeah.
sure,
Yeah.
right? Because heat is just multiplication.
Yeah.
Heat is just um, right. So that makes sense, right?
Yeah, that makes sense.
Right. So just want to make sure, just make sure you write down all these equations. Heat is multiplication, right? Is your heat equals specific heat times mass times temperature, right?
Yeah.
And then everything else you just you just divide, right? Because if you were looking for temperature, then the equation would be the same thing, right? If you were looking for temperature, you just move temperature here, and heat is always going to be at the top, and the rest is going to be multiplied at the bottom. And you divide that.
Yeah.
So if you're looking for specific heat, is C equals Q mass times temperature. If you're looking for temperature, it'd be heat, specific heat times energy, right? If you were looking for mass, it's the same thing. Mass is Q times specific heat times temperature, right?
Yeah.
Does that make sense now?
Yeah, that makes sense.
Okay, and then in the practice questions, and when sodium acetate, a solution, is dissolved in water, a solvent, the temperature of the solution decreases, right? What does that mean?
Yeah. It means that the
When we say when the temperature decreases, it's endothermic, absorb. When the temperature increases, exothermic, release.
yeah.
Right? So is
Yeah.
this energy used to break bonds between the solution, between the solute particles, or used to form bonds between solute particles in the solvent? Um, when you endothermic is always to break bonds, exo is release, absorb, break, formation, 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 release. Does that make sense?
Yeah, that makes sense.
Okay. So there's like one thing we haven't talked about, and I know that we're going over time a little bit. And that is calorimetry. But all of this makes sense, right? All of this, because all of this is going to be on your test. That's what it looks like based on this practice test. I just reviewed all of your practice tests except for your scientific notation, which should be straightforward, right?
Yeah.
Right, you get those? That makes sense to you?
Yeah, I get that.
Okay. Okay, so that means the only thing that I haven't gone over is calorimetry. 1 second, let me just blow this up. This is calorimetry. Let me just. They always do that. Sorry. All right, so in the question that you had in class, it says, you know that 1 cal is 100 kilocal, right? I mean, 1,000 kilocalories, right?
Yeah.
Right, okay. So here, I'm gonna show you something that I don't know is something that you guys will do right now, but I'm gonna show you something that integrate all of these questions, all of calorimetry, enthalpy, and heat transfer. Okay, because all of this, all in all together, is pretty much just telling you the same thing. Energy released and absorbed, right? We say that calorimetry is a process of measuring the amount of heat released or absorbed during a chemical reaction, right? By knowing the change in heat, it can be determined whether or not a reaction is endo or exothermic, right? So this is, again, another way of applying endo and exothermic reactions and heat flow by, and then she can test you this way. I'm not sure. She might, I don't know. Knowing your teacher, she might actually do it. So this is just an example, right? Step 1, like I told you, list the known quantities. List your known, list your known, list your known. List your unknown. What are you looking for, right? What are you looking for? Here is an example, right? This is calorimetry and enthalpy integrated, right? In this experiment, you have 5 milliliters of 1 ml of HCl at 25 Celsius is added to 25 ml of 1 mol of NaOH at 25 Celsius, right? A foam cup of calorimeter. And I'm only showing you this as well because a lot of your homework was like this.
Yeah.
Right? Does this look familiar to you?
Yeah, it looks familiar.
And I'm thinking this is how she's gonna test you. Right. So a reaction occurs and the temperature rises to 32 Celsius. Now she wants you to find enthalpy in kilojoules. Assume densities of the solution are 1 grams per milliliters and their specific heat is the same as the water. Right? Because we said that the specific heat of water is what?
The specific heat of water is specific heat of water
In this case, I think in this case, they want us to just use this 1 gram.
yeah, the one.
Right.
Yeah, the 1 gram.
So now we're saying that our known values are going to be your specific heat, right? Your specific heat of water is 4.18, right? We said that on your page, right? 4.18 joules per grams Celsius, right? Right? And then they're giving us volume, right? Our volume final, this is, our volume final is 25, right? 25, right? Plus
Yeah.
25 equals 50 mils.
Yeah.
Right, our change in temperature is 32 minus 25, which is 7 Celsius, right? Our density is 1 gram per mil that was given to us, right? Now, what is our unknown? Our unknown, we're looking for enthalpy. Delta H, we're looking for delta H. What is delta H? Right, now that you have your knowns and then you put down your unknown, now you can solve, right? Right.
So
So here's the deal. You probably haven't seen this equation. Delta H is equals Q system, and that just telling you endothermic equals negative Q system, which just tell you those that are released, right?
yeah.
And then you equal that out to negative mass times specific heat times your temperature.
So it would be so it would be 25.
First, you have to find out your mass, right? Your mass
Yeah,
is already given to you.
so a mass is 1, right?
Your density is 1, but
Or
your
our density is 1. Mass.
mass is, you have to use the volume that was given to you. Are you there?
Uh, yeah. I
Times,
think I did the 1.
grams. You just have to switch the units here, but it's literally 50 grams, right?
Yeah.
50 grams. Your mass is your volume times 1 gram, which is your density, divided by milliliters, which is 50 grams. Right. And now you have complete information. So now you're looking for delta H, right? And we said that it's negative, whatever, 50 here, which is 50 gram mass, times your water specific heat, 1.8, right? 1.8 joules. Make sure you're putting down all your units, right? Times your temperature, 7 Celsius, right? And then once you do that, then you are able to get your heat as 1463. Now, if she wanted you to round this, right? If she wanted you to round this or maybe put it on scientific notation, you'd be like, okay, this is 1.5 times 10 to 3 joules, kilojoules. And this would be negative, and that would mean that this is an exothermic reaction. Does this make sense?
Yeah, it makes sense. what's wrong with my camera? It just keeps going on and on. Yeah.
What'd you say?
I don't know if like the camera's broken or something. It just keeps going on and on.
Okay, it's fine.
Yeah.
Do you get what this is all about?
Yeah, yeah.
Okay. So that's, I just wanted to like integrate that right there to make sure that you're able to like think about this for your exam. Right, I know that it was very simple, whatever calculation you had on this test. And then it looked like you were able to calculate the last question, which was looking for, calculate the final temperature.
Yeah.
And you were able to do that perfectly.
Yeah, and my teacher helped me like with like the first part, and then I just got it from there.
Awesome. Well, doesn't it help when you write down all your knowns first?
Yeah.
Okay. Temperature, I want me to. Okay. So she gave you the initial temperature, which was 150.5. What about T final?
T final was I
200
don't know. Yeah, it was 200 and like I'm not. I don't have the page in front of me, but it was,
because Kelvin is 370, huh?
yeah.
Total is 370, so minus 150, your T final is whatever's left out.
Yeah.
Okay. So just, it looks like when it comes to like, the stuff that, I think the only thing that we didn't really practice last time was math, so I can see why that kind of tripped you up. But everything else you were able to do, right?
Yeah.
So you feel comfortable about this information?
Yeah, I do.
Okay, so we talked about, energy transfers and all of that. And endo and exothermic, convection, radiation, and conduction, which is going to be on your test. And then these are all the things that we didn't really get to talk about, which was the calorimetry. Calorimetry, I think, is it the calorimetry paper?
Yeah, I completed everything because it was due I believe that day, so I did that, and my teacher said I did a good job on it.
Huh?
I completed it and everything because it was, I guess, due. I didn't know it was due that day, so I did it, and then my teacher said I did a good job on it. So
Okay, so you feel comfortable with this?
yeah, I did.
Okay, all right. All right, well, I put this on here because I wanted to just have a, to make sure you are understanding this, which is kind of like what I said is, calorimetry is just applying the specific heat and the exo-endothermic reactions into calorimetry, right?
Yeah.
Which is why I gave that example, right? Okay, do you have any questions about anything here and or this this paperwork that you did for your homework?
I do not.
Because this was kind of a lot. And you feel comfortable about this as well?
Yeah, I do.
Okay, so I'm just gonna do this one last time. What we reviewed on Monday so that you can feel comfortable. Which was on Monday. Save. This was what we did on Monday, presentation 3, right? This is the significant figure scientific notation. You're good with this, right?
Yeah.
heat flow, right? We talked about this, right? It always go from higher temperature to low temperature, right? Right? The different, remember this, if you're given this table, remember? If you're having to calculate heat, you know what to use, and you multiply everything, right? Right, and even with this, when you're using calculating for a specific heat, and then ultimately mass, right? Okay, so this is what I'm gonna do. I'm going to save this. Actually, I'm going to print this. I'm gonna just send it to you all in an email right now, so you have it. Save. This is 11. What was that on Monday? Was that 20? Was that the first? Jeez. Time is going by fast. Okay, and then this one, I don't know if any of my PowerPoints helps you.
Yeah, they do.
But I'm gonna just go ahead and save this and send it to you as well, so you have this. Save as, no, I did print. Notes. Sorry, my thing just died. Oh my God. Oh. Okay. Save as PDF. What is this? 11/4/21. Desktop. Okay, and then there's also some notes on here. Man, there's so many things on my screen. Yep, there's a million things on my screen. Ignore it. Okay, I'm gonna just go ahead and send this to you and your mom, so that they know everything. Is it Priscilla, Matthew, Devin, and then chemistry. I'm gonna just add this here. Do you spend some time to review this pages that I sent?
Yeah, I have them all printed out. Oh, I have one of them printed out. I'm not. I think it was the second one we had went over. I had printed it out, and I kind of studied that and everything. I read through the text and all that.
Okay, and it helps. Okay. Okay. Well, I think, what time is it? Almost 7 o'clock. We'll just end here. We kind of went over a little bit.
Yeah.
Just because we were trying to make sure everything was done. You feel comfortable, right? And we went over your test, your practice test,
Yeah.
right? And I'll let your mom know.